Apollo 11, this is Houston. If you go ahead and cycle pitch gimbal motor number 1 on.
In a world where great achievements are built through the efforts of many, where we can achieve unimaginable things by making each challenge a stimulus to continue, humankind craves for even more progress by looking at the stars for the necessary energy to make it. Here, the Sun, our great star, is where one of the most powerful reactions in the universe takes place. The fusion reaction, an endless source of energy that not only makes our existence possible, but it is also a scientific inspiration to progress and to protect our planet. Every second, millions of tons of hydrogen nuclei react with each other under high temperatures and pressures. When hydrogen nuclei join under these conditions, they produce heavier elements, releasing a large amount of energy. The use of energy extracted from different sources is essential for our survival. However, current energy sources are not enough for a planet that has abused of its natural resources to unsustainable limits for the sake of development and progress. This is the reason why we are now facing the great scientific and technological challenge of looking at the Sun, trying to replicate its fusion processes and make them possible in a controlled way here on Earth, as a way to find a practically unlimited source of energy that is environmentally friendly. The next step to achieve this challenge is a reality already. Its name is ITER. ITER is a large-scale experiment designed to demonstrate the scientific and technical feasibility of fusion as a new source of energy. This great challenge brings together the efforts of over half of humanity towards the same goal. And it is the Fusion for Energy Agency, based in Barcelona, the one in charge of combining the European contribution. The heart of ITER project will be the largest tokamak in the world, and in its vacuum chamber a replica of the collision of hydrogen atoms will be produced. This will release their energy just like in the Sun, but in this case in a controlled space and using, rather than normal hydrogen, its heavier isotopes, deuterium and tritium, allowing in the future to control and use this energy. After the research, tests and technological advances developed at ITER, its successor, the demo demonstration reactor, will be built, the forerunner of commercial fusion reactors, as it will have to demonstrate not only that it can control more energy inside than ITER, but also that it will be able to generate it in a continuous and stable way to be used at all levels. ITER and DEMO will therefore become the great challenges to achieve and take advantage of fusion energy on Earth. But between both projects there is, among others, an intermediate, fundamental and essential step in which Europe and Spain are positioned at the forefront of scientific and technological powers in the field. Its name? Ifmif Dones, a facility intended for the study of materials essential to achieve fusion energy. Ifmif Dones will make it possible to study the behavior of materials under the intense neutron flux to which they will be exposed in future reactors, an essential step on the way to design fusion plants. After the agreement between Croatia and Spain, and with the support of Fusion for Energy and Eurofusion, Granada has become the European bid to host Ifmif Dones. This site has positioned itself as the strategic location for the construction of a facility of unique characteristics in the world. In an area of 100,000 meters squared, the main systems and technical equipment necessary for this scientific facility to start up will be installed. Ifmif Dones will create neutrons to replicate the irradiation conditions that will take place inside future reactors. But how it works? What will happen inside the Ifmif Dones? The journey begins with deuteron gas, an isotope of hydrogen. In the injector of a one-of-a-kind particle accelerator, these atoms are ionized and are prepared to start their journey. Throughout the accelerator, the beam of deuterons will acquire more and more energy, more speed, and will go towards their objective, the target, a curtain of liquid lithium located at the end of it. The impact of the deuterons on that lithium curtain will generate a large number of neutrons. These neutrons will interact with the materials under study, modifying their properties, simulating the irradiation conditions that the materials will have in future fusion reactors. During the years of operation of Ifmif Dones, different types of materials may be studied and different types of experiments will be carried out. The technological possibility of imitating the fusion processes of the Sun here on Earth involves studying and verifying that the materials used in the construction of fusion reactors withstand the conditions they will be exposed to once they come into operation. Therefore, it is essential to contribute with data and results obtained in the research carried out at Ifmif Dones. We are going to build a unique facility in the world. Therefore, in addition to its importance for the development of fusion as a source of energy, it will also be important for other research areas and knowledge that may benefit from its technology, such as medicine, particle physics, basic physics studies, industry, among others. All this in a planet increasingly committed to sustainable development and the use of a clean, safe and efficient energy. The future has begun, and Europe, Spain, Andalusia and Granada are strategically positioned with their contribution to the ITER, DEMO and Ifmif Dones projects at the forefront of technological development and global innovation. We are facing one of the greatest challenges of humankind, an ambitious project with economic, technical and scientific challenges. But thanks to our talent, intelligence and passion, we will manage to succeed, outstandingly contributing so that fusion can be a part of the energy of our future.